Yeah, today, thanks for coming to our presentation. The main focus of our talk today is we're going to be talking about how we have leveraged NLP within our startup environment to deal with business challenges that we've faced. So primarily assessing climate disclosure alignment, so the alignment of corporate financial reports to different climate frameworks and standards. So the topics we'll be covering today, first a quick introduction to our business, Manifest Climate, what the main business problem is and the NLP application, our model experiments that we've run, and some of the main challenges and takeaways from these experiments. So to start out, we're from Manifest Climate, which is a climate risk planning startup based out of Toronto. We have about 60 people, and what we do is we help to support organizations on understanding, managing, and then communicating their climate-related risks and opportunities. So we have a software product, but we're also supported by climate expertise. Our data team at Manifest is made up of 4 full-time people, and we cover everything data related within the organization, so from data engineering to analytics. This includes like product analytics, operational analytics, then also machine learning as well. So the main focus for this talk is what we refer to as a climate disclosure review. And just for some context here, in the past few years especially, there's been kind of a global push for increased climate reporting from corporations. So this comes from investor pressure, it comes from regulations that are starting to appear throughout different jurisdictions. So companies from all regions, all sectors are being pushed to align their corporate disclosures to these frameworks. And one service that we provide as an organization is what we refer to as a climate disclosure review. So this involves having our climate experts review a company's financial reports. So this could be anything from annual reports, proxy statements, ESG reports, anything published by a company, and then extracting information from this to assess that organization's alignment with a climate standard. So in order to do this in a systematic way, what we have to do is extract particular categories of climate-related information. So these categories or groups of information can be grouped into different classes, which are shown here. There's a lot of different types of climate language, from things like board supervision of climate, climate scenario analysis, climate metrics, climate targets, and some other groups that are listed here. So that means that once our climate experts perform this review and extract text that aligns with these classes, we can kind of provide an overall assessment or like a score of how well a company is aligning to these different frameworks that are appearing. So one of the main challenges with this is that it's incredibly time-consuming. So each organization always has multiple reports that they're publishing, and these reports are often hundreds of pages long with climate information kind of spread amongst these different reports. So for our climate experts within our organization, it could take many hours or days to review these reports. And so the solution that we've introduced is building NLP models that look at this text in the reports and automatically classify the text into these climate categories so that our climate experts in-house have an idea of which areas are or which parts of these reports are important to review. And so that creates this system, which Tien will get into a little bit more. But it's basically this human-in-the-loop system where we have our climate experts who are taking these reports and extracting any information that aligns with those 11 climate categories, which creates a labeled data set for us. We then use this to train our machine learning models, which are then applied to the raw reports, and then these reports, which are in PDF form, get tagged so that our reviewers have an idea of what is important and what is not important, and their process is much more efficient. So I'm going to hand it over to Quoc Tien now to talk a little bit more about our experiments and data.
Cool. Let's start building models. And before that, let's start gathering good data. So we know that good data is where all the magic happens. And when we started, we had basically all the data and processes in spreadsheets, lots of spreadsheets, which are obviously not like pretty difficult to access and get the data. So the first thing we did was building some ETL pipelines and setting up a very simple data lake just to get this data so we can produce analytics and train like POCs with machine learning. But we also want to play the long-term game. So how do we get more data faster and better? Because we noticed that the data collection process was very slow, and we were not sure about the quality of the data. So we tried to find, like, to buy a third-party tool to annotate data. Unfortunately, we couldn't find any that would fit our needs. So we had to build this internal web application to collect data at scale. It's basically a Flask app that we built and that the climate experts in our teams use to perform the reviews that were described earlier. And that way, we can actually control how the data is collected. We can write tests. We can make sure that the data is of high quality, and we know that now it sits in a nice database, which is great. Okay. So just like in the previous diagram, it just like fits here. But it really, like, the collection process is half the time now compared to before, which is a big win for us. All right, now let's start talking about modeling. So I just want to go back to the context we are in, which is a startup. As a business, we're trying different things, we're experimenting just to find product market fit. And it's a very unique situation where all the teams try their best and iterate very fast and like try new things, fail, succeed. And it's very hard to build ML products in that context because they are usually like uncertain, risky, and take a long time. But we want to align those two like objectives together. So sometimes your ML product will open new opportunities to the business, and sometimes you only need like incremental changes, like we need like a good analytics or like a good POC, and that works. So we just need to like be mindful of how the business evolves and evolve as fast as the business does. All right, so first model, that's how we came up with like the process. We started with like a very simple POC, like a proof of concept, which was a binary text classification. So Aysha told you about the 11 climate categories. We just started by trying to do a binary classification, which would tell the climate experts if a text is climate relevant or not. And that problem itself actually had a lot of use cases in our teams. So we just like doubled down on this, and the actual modeling, like the training of the model, actually took like a couple of weeks because the problem was well defined. And so we put this model into production into our internal tool, and this simple model that I'll show you after is actually was used like for a few months, like for a lot of months, and kept delivering value over all these months. And we could gather feedback from them, what they really needed to do, or like what they needed us to do for them. And for those who are familiar with NLP projects, I think you probably know about this, but this is basically the baseline that for any NLP project. I can go a bit into details, but like from the PDF file, we extract the text, which is its own challenge by itself. We can then clean the data with some classic NLP techniques like removing stop words, stemming, identifying keywords and phrases and stuff like that. Once the text is cleaned, a TF-IDF vectorizer, so it just gives like a importance score to each keyword and phrase, which then feed into the classifier. So in our case, it's like a classic random forest. So very simple, but this model was used for a very long time because it fits our needs perfectly. All right, second iteration. We actually did not do much on the modeling side of things. Because we built this data collection tool that would give us more and more data faster and better, we just basically retrained the model that we had. And that was just enough to give us a 10% jump by doing nothing on the modeling side. So I mean, not nothing, but we maybe improved the text cleaning, we more domain knowledge. We retrained everything in the pipeline, and also we extended the task to a multi-label classifier with 4 categories this time. Why 4? Just because the 11 categories were a bit hard to do at the time, and just having information about those 4, which is more overarching categories, was enough for us as a second iteration. So modeling side was pretty fast. We just retrained that and had really good results. All right. Third iteration I will show you now is a bit more complex. So once we have these 2 models in place, they're running, they're useful, the business has evolved. And more complex use cases appeared. And we needed to a tight collaboration between different teams in our business. And also we need to experiment some stuff to show them what is possible and what is not possible. And that process is pretty long. It's a couple of months, lots of back and forth, understanding what they want, what the business wants. For example, the product that we sell to our customers change, and that just changed a lot of things for us in the data team. On the right side of things, we also try to extend all the use cases possible, all the POCs that we can do to show the value of ML to the business. So before we only had this one use case in our internal app, but we wanted to expand because that was pretty restrictive. And now we can have POC for the product itself. Can we just put one feature in the product and see how the customers react to that? We can also work with the sales and marketing teams. We publish some white paper or blog posts on our social media and blog. And inside those blog posts, we can just provide ML-powered numbers and figures and stuff like that, just to show what we can do and how customers and prospects react to that. So we don't have to only build ML-powered features that are integrated into the product directly. You can also have different ways to show and to test our models. But anyways, that's a whole process, very iterative. This is kind of the latest model that we ended up with. We tried a bunch of different things. We actually wrote a paper that will be at the newest workshops called Climate Change AI next week. So if you want more information about the models and the experiments and the results, all of that, feel free to check that. But as an overview, this is kind of the latest model we want to implement very soon into our product. But it uses a sentence transformers embeddings to encode the text. So we just use a pre-trained DST Roberta model, the easiest, fastest to get to the value. Then we use, step back. We have more data, but we still have little data. For each category that Aysha told you before, we have maybe thousands or tens of thousands of data, which is not much, or even few hundreds for some categories. So it's very hard to train a deep model. So we tried using this multi-label KNN, which is a Bayesian variant of the KNN. that gives you like probability scores for each of your label based on like the k neighbors. The k neighbors are found using the cosine similarity on the embedding space. So we have these scores, but we also wanted to add some domain knowledge rules. So we have like this, these two arrows that come from the multi-label KNN, also business rules, and so we just add like a basic neural network at the end, just to combine the business rules and the results from the multi-label KNN to give us the final classification score for the 11 classes. Okay. This next slide here is kind of the same model, but what we want to explore next. First of all, fine-tuning the language models. Like this is what what works usually, like to fine-tune all data. We haven't done that yet, but definitely the immediate next step is to do that, just so that the language model has more context about our type of data. And second thing is like to find ways to combine the business rules and the classification algorithm a bit better, because we can be as precise as having one rule or one combination per category. So we can go very deep into how to stack models together, and that's really how we think is going to improve the models the best. Maybe like one model per industry, or like one model per category, or thing like that. And also the thing we haven't told you is that we actually don't have only 11 categories. We have like more than 300 data points that we're actually interested in. And so the problems become even more complex. We have like these 300 data points of categories we want to predict, and some of them has like no data, or like no label data, basically. So how do we deal with that? Thing I forgot to mention is that why we use these models is because they are very easily explainable. We really like the KNN variant because we can actually show the climate experts like similar references, or like similar like climate texts, and explain to them, oh, why does a model predict that? Oh, it's because we saw in the previous text that is similar. And then we also take into account what they tell us, like what their domain expertise tells us, and it is encoded into the business rules. So it's very explainable, and people trust it, and we have a strong buy-in from different teams, which is great. All right, just to summarize kind of the challenges we faced. First one was when to use ML and when to use domain climate expertise. So it's a very complex field. We don't know if ML is going to work for all the use cases, but we want to make sure that we have the best combination between those two. Second one, as Aysha mentioned, we're a small team. There's not only that, but all the data engineering that we need to do, data analytics, ML ops. So it's very rare that we can focus 100% on modeling only. So we need to find the best projects that would deliver value the fastest within our constraints. Third one, as I told you before, is very hard when the startup is pivoting and moving in all directions to push for some ML products that will take 3 months to develop. 3 months is a lifetime in startup life. And last one is a challenge, but it's also a fun thing. It's educating your teams about what ML can and cannot do. And that ties with the fact that I told you before, we try to expand our use cases to more than just ML-powered features in the product. We talk to sales, marketing, product, whatever, just to find some small use cases and tell them, oh, hey, that could be useful for ML, and show them how it works. Anyways, that's all. That's the takeaways.
Yeah, so I'm just going to wrap things up today to talk by talking about some of the major takeaways that we've had through doing this work, and I guess learnings that we want to communicate as well. So the first thing is that it's so important to be continuously collecting this high quality data. So like Quoc Tien was mentioning before, at the beginning when we started, we had all this data in spreadsheets, which was very messy and also difficult for us to use. But then when we built this data collection system, that on its own improved our model performance significantly. So the next thing is starting with simple models because they often do the job. So what Quoc Tien mentioned before is that first model iteration we had was very simple. It was a TF-IDF model with a binary classifier, and that kind of addressed the business problems that we had at that time, which leads into the final point, which is evolving your ML models as the business needs arise. So as our startup and our product was evolving, what we needed was more complexity, more being able to create different predictions with those additional categories and what we want to expand to more as well. So only when those needs arose was when we did start to implement more like state-of-the-art models into our systems and experiments. So that wraps things up for today. Our contact information is at the bottom here. We're also happy to answer any questions that you have, and we'll be around for the rest of the day as well if anyone wants to chat. Thank you.
Oh. Sorry. So the question was.
Performance metric for
Yeah. Yeah, performance metric. We use the AUC under ROC AUC because we always want to make sure like precision and recall are what the business needs us to be. So the AUC was the best metric for us to evaluate that. And then the actual threshold we choose, that's like purely business like oriented. Yeah, so not sure the number, but yes, like there was like a difference in some categories only, where BERT style models were performing best, and our assumptions or like our interpretation is that some categories are based more like the semantic of the paragraph. Like for example, we are looking into like strategic thinking of companies, and that's like hard to do in like some keywords. So in those cases, like those transformer-based model work best, but sometimes we have like climate matrix categories, and that's like usually like a couple of words or like 2 tons of CO2. So in that case, like keyword-based models like kind of perform the best because they're very discriminative. The label? So that's the thing we showed you, like the data collection thing. The tool that we built, that's how we get all the labels. So like the disclosure review process that the climate experts are doing, that's how we get all the labels. Yeah, we have like a team of climate experts that do these climate reviews of documents. And when they do that, we store all these results, and that's all labeled data sets. Yeah, so that's like the first use case we had, with like how to help the climate experts do their job, faster or more efficiently. But then, as I said before, like we try to expand the use cases. So it's not only that now, but we use the same labeled data to actually build features that will be in our product that we sell to our customers. And we also use the same labeled data and same models to produce like marketing assets, or like show things to the prospects when we call them, or like things like that. So it's very different.
Yeah, thanks for the interesting talk. I'm a bit curious as to how you like a little bit about the PDF tagging.
Yeah.
It kind of seems like you'd have to break down like your documents before you classify to do that, right? Like, what level do you break it down? Is it sentence by sentence? Do you find spans? Like, how does that work?
So yeah, that's like a problem in itself. Like, how do we extract text from PDFs? Right now, we extract the raw text with some libraries, and depending on the documents itself, sometimes we have like nice structure. We know where are the paragraphs, where are the sentences, where are the images, where are the tables, and stuff like that. Some other pages we don't know. We just have like a line of text without any delimiters. But we want to also work on that like separately. Like, how do we extract the information for the PDF the best way possible? And I know that there's some like models, like transformer models, to extract the layout of the PDFs. Like, this is an image. This is like one paragraph. This is like a title or whatever. So we want to experiment with those too in the future, but definitely like a big problem.
So for now, it's sort of manually engineered.
It's like a library that we call. It's called like, I'm not sure what. There's like some Python libraries that can extract the text from the PDF,
Okay.
and we use that. And we
And
don't really control the quality.
And you'd grab like section by section. Is that how you do it, or the whole thing? You just throw the whole thing in.
We check the whole thing, and then the models are trained either at the sentence level,
Okay.
sometimes at the paragraph level when we have the paragraph, like when we know where the paragraph is. And for example, the TF-IDF was trained on the page level. At the page level.
Cool. Thanks.
Thank you for the presentation. It was amazing. So I was just wondering, based on the name of the talk, you guys are probably focusing on financial companies and their climate documents. Have you guys tried other industries and were the results similar? Could you use the same model for them, or did you have to look at other models, just changing the business rules work? Like, how was your thinking regarding that?
Oh, yeah, so we're not just focusing on finance companies. That is one of the sectors we look at. I think the title, Assessing Climate Disclosure in the Financial Markets, is because we're looking at, a lot of the time, financial reports, but from companies across any sector. So it could be, yeah, finance is a big one, but also, real estate, retail, industry, yeah, lots of different stuff.
So the model you guys have is very generalized regardless of what domain we are talking about.
Yeah, currently, but like Quoc Tien said, future area of exploration is sector-specific models, because the language that they use, even within those categories, can differ.
Makes sense. Thank you.
With the granularity in the plugging in the final process of the KNN to the BERT result?
Yeah, how? So the multi-label KNN gives a probability score for each of the classes we're interested in. And then we just add like some business rules as features. So for example, like the multi-label KNN gives you like.
So what the result
Sorry.
transformer-based embeddings fed into the KNN?
Yeah. Sorry. So we encode.
Labor, is that it, or
Sorry, what?
probability of each labor?
Yeah.
The transformer?
No, sorry. I go back. So each piece of text, either sentence level or paragraph level or page level, whatever makes sense. In our case, it's mostly like paragraph level, are encoded with the sentence transformers. So we have these input features of like 762 dimensions that is then fed into the multi-label KNN. The multi-label KNN gives us scores for each of the 11 classes. So we have 11 scores. And then to those 11 scores, we add some business rules. So it could be like, is climate scenario in the text 1 or 0? Or like how much GHG emissions this company disclose or whatever. So we add like this bunch of features, and then we put all these features combined into like a next classifier, which gives the final 11 scores for the 11 classes. Yeah.
I think we might have to wrap things up, but we'll be around here afterwards as well if there are any other questions. But thanks again.
Yeah, thank you.